I'm going to give you a very extremely brief introduction to weak base equilibrium problems. Ammonia in water is a base, so that makes water the acid. And this is your Brownsted-Lowry relationship. As you see, the water structure will transfer a proton to the ammonia, forming the ammonium ion and leaving behind the hydroxide. The pH of a strong base is simple. You simply take the negative log of the hydroxide ion concentration. That gives you the pOH, and then of course subtracting from 14 gives you the pH. Remember, all hydroxides are strong bases. They dissociate 100%. Even if they're not soluble, when they undergo an acid-base reaction, they will react to completion. Go ahead and calculate the pH of a solution prepared by dissolving 1.56 grams of sodium hydroxide in enough water to make 200 milliliters of solution. So you're going to use the molar mass and the volume to get the molarity and then negative log it. Stop the podcast at this point until you've solved the problem and then start it and check your answer. Hopefully you were able to get a pH of 13.29. Quite basic, which is what you would expect from that strong alkali solution. Weak bases undergo, just like weak acids, an equilibrium situation. So here we've got a base represented with B, so B plus water, and again you're going to transfer that proton from the water to the base, forming a positively charged species and leaving the hydroxide ion. Again, when you write the equilibrium expression, you will leave out that water in the expression so that you have your typical equilibrium expression with the conjugate acid, the hydroxide ion, and the base. The larger the Kb, the stronger the base and the more dissociation there is. Base plus acid means that ammonia, being a base, will form the ammonium ion as the conjugate acid. The conjugate base of water is the hydroxide ion. All weak bases, or most weak bases that you'll encounter, are amines. They are simply derivatives of ammonia. So ammonia's structure has a central nitrogen with 3 hydrogens and a lone pair of electrons. So you will end up putting other groups on here other than the hydrogens, and these will all behave very similarly to the simple ammonia molecule. So methylamine is the ammonia with one of the hydrogens with a methyl group. A methyl group contains 1 carbon and 3 hydrogens. Dimethylamine, notice the amine is a big hint that this is a base and a weak base. Dimethylamine has 2 methyl groups. Trimethylamine, 3 methyl groups. Ethylamine would have an ethyl group, 2 carbons. So you're not really going to have to draw the structures of these at this point. Just recognize that they all behave like the simple weak base ammonia, even though their structures are a little more convoluted. Caffeine is a base. Notice it ends in INE. These are amines. Again, you can see the nitrogens that would lead to that structure. Morphine is an amine. Any compound, typically in organic chemistry, ending in an INE is a base of some sort. So let's look at a typical weak base problem. Again, just like acid problem, we set up our ice. We've got a 0.1 molar ammonia solution. We want to know the pH. We put our x's in. We set up our equilibrium at 0.1 minus x. So you've got x squared over 0.1. The only difference is, of course, since this is a base problem, we have a Kb. Anytime you have an OH negative, you're going to have a Kb. When you find x, don't forget, it's the hydroxide ion, not the hydronium ion. So when you take the negative log of it, you have found the pOH. You'll need to subtract from 14 to get the pH. Solve this problem by yourself, 10 molar ammonia. See if you can find the pH. I'll get you started. Stop the podcast. Solve the problem all the way through until you can find the pH of the 10 molar ammonia solution, and then come back and start the podcast and check your answers. Hopefully you were able to get a pH of 12.13. You would expect a basic pH because of the hydroxide ion. Try another problem. This is methylamine. I've given you the reaction, although it would be very similar to ammonia. You've got your base, and you actually don't always have to write out the structures unless they tell you to. You could simply substitute, like we do HA for acids. You can do BH plus for your base and conjugate acid. Again, stop the podcast, solve for the pH, then restart and check your answer. You should have a pH of 12.32. We'll work on weak base problems more tomorrow. Make sure that you understand weak base and weak acid problems are essentially the same. The only difference is you're using a Kb value, and when you negative log, you are negative logging the concentration of hydroxide, and that gives you POH, and you must subtract from 14 to get the pH.